numbers that I want you to memorize, and these are simple tests that we can do. We talked about an air conditioner. That's going to be a 15 to 20 degree temperature drop. All right. So as we measure the incoming air to the exhaust, 15 to 20 degrees. A heat pump in standard heat pump mode, so the furnace in this situation or whatever additional heat that they have isn't operating, is going to be typically a 10 to 15 degree temperature rise. Air conditioning, 15 to 20 drop. Heat pump, 10 to 15 rise. All right. If that's not enough to heat the house, and we go a little bit further, then the auxiliary heat kicks in. So whether we call it auxiliary heat, emergency heat, I don't really care. All right, it's really the same thing. Sometimes people will make it a furnace. In this diagram, we're showing an electric furnace. So that electric furnace is our auxiliary heat. So instead of the heat pump running now, the auxiliary heat is going to be running. Now that varies depending on the furnace that's installed for this. Typically we could find this temperature rise on on the furnace itself. Here they're saying it's 40 degrees for the temperature rise. And, I've been finding that varies. I've seen anywhere from 25 to 55. I've seen 50 to 80. All right. So looking at that data plate, I think, is more important than looking at these diagrams and memorizing these numbers. But if you're going to be taking a test, then that 40 degree number should be a pretty decent number to memorize. All right. Geothermals, they kind of work on the same principle as the heat pump. We know that about 5 feet and below, that the average temperature of the Earth is going to be roughly around 50, 55 degrees, somewhere in that ballpark. All right. So instead of having an air conditioning coil where I'm absorbing heat from the air, instead of having that present, I'm actually going to use the heat that's present in the Earth. So most air conditioning systems that we have are what we call air-to-air systems. I absorb heat from the air inside the house, and I discharge heat to the air outside the house. If I want to use it as a heat pump, I'm going to absorb heat from the air outside, and I'm going to discharge heat to the air inside. If I'm doing a geothermal, like what we're seeing in the diagram, I'm going to absorb heat from the earth, and then I'm going to discharge that heat to the air inside the house. And even if I ran it in reverse, I can also discharge heat to the outside as well when it comes out that way, or to the earth as well. So if I'm going air to earth, it's a geothermal. They actually have well air conditionings, and a lot of people refer to those as geothermals as well. So what they'll do is drill a deep hole, and just like they would be drilling a well system, and they would run their refrigerant tubing into that well so that would be absorbing or discharging the heat that's present as well. Those are how geothermals differentiate from anything else. Cooling towers, I don't want to go into these too much. Honestly, it's kind of over my head. So usually high-rise buildings, large commercial buildings, you're going to see cooling towers where they're actually going to be running water over the exterior coils. The idea of the water flowing over it is it's going to be absorbing more of the heat out of the refrigerant when that works with it. They're common. You're going to see them if you get involved with commercial inspections or if you start dealing with condo buildings as well. And with some condo buildings, they're just going to have air handlers in there. So I think we're going to talk about that in a minute. Most common type is the aqua tower. And again, water is used to cool the compressed coolant over the evaporator systems. All right. So just a couple pictures and a few things that we end up seeing here. I like this picture because it shows the tubes that the refrigerant is actually running through. And then it also has the fins on there as well that the air was flowing through. Now this happens when a dog urinates on the air conditioning system. those fins are very thin and they're fragile. All right. So a dog's urine sometimes is pretty acidic. So if they keep peeing on the air conditioner all the time, then it wears away at the fins. Now, it didn't hit the copper tubing. It didn't damage that. But the fins that are on there, that it did damage. All right. So, but the tubing itself is where the refrigerant runs. And then those up and down fins, you can see how tightly spaced they are together. So we get a lot of airspace that's touching the metal that's on there when it runs through. We do have to keep those clean. Speaking of which, I'm looking outside my office window right now. And yeah, I got a pretty thick cake of dirt on my outside fins. So I got to get those hosed off and cleaned up. But don't tell anyone, please. Especially the lovely bride. All right. So I did go about 2 hours. I hope this was helpful. I'm more than happy to talk about any questions if anybody has anything that they want to put up here. And I'm not trying to escape. I know it takes a few minutes to type, so I will sit back and hang tight for a little bit. I am going to start up again at 1 o'clock, and then I'm going to continue the plumbing section on this one. It goes a little bit quicker when we don't have a lot of questions on there, and I know in this type of environment it's not always an easy way to do things. But nonetheless, I do hope that this was helpful for you guys. I hope it gives you a better understanding. It is going to stay up there on that YouTube channel, so if you do want to listen to it again, feel free. But as far as I'm concerned, I think it's kind of important that we understand how air conditioning systems work and some of the problems that we run into these things. All right. So I'm going to take myself off the screen. I'm still here, but I just don't want to look blatantly dumb in the picture. But I'm just going to sit tight here until basically everybody's signed off. Gotcha. That's a nice thing to add. So Mark jumped on there. He said he thinks the ductwork works like a heat pump. They just use heat exchangers and every place that you want to have heat and cold. And I have seen these things that are smaller units that are up over the door, and they're basically per room. I think you're 100% right. And I don't know if they all use the same air compressor on there or if each one has its own. You know, like I said, I don't see too many of them in my area, and I'm not afraid to say I'm ignorant on the subject. All right, guys, without anything popping up here, I'm actually going to stop this. And thank you. And again, I hope this helps.